All right, let's talk about the stringer angle and how that affects your length from the outside edge of the deck where the top of the stringer is attached, basically measured from the ground to the center of the concrete pad that you pour where the bottom of the stringer is. So the biggest thing that's going to affect that is, are we on level ground? If we're on level ground, that makes calculations easier. If we're not on level ground, then you're going to have to put a board, probably a stringer board, on the high side, and then measure out towards the deck or away from the deck, whichever it is. So if the high side is over here, then you're going to put your board here and put a 6-foot level on it when the bubble is just right. And we're assuming the grade goes down here. Then you can measure from the bottom of the board here to the ground, and then you can measure from the here to the ground, and you can add that extra space on there to give you your total height. Or if this side's the high side, you can put your board up here and hold it out level, and then measure from the top here of the deck to the bottom of the board here, and that's going to give you your total height. So that'll give us our total height here, which for this example, I'm just going to say is 15 foot. Okay, so now what else is going to determine this angle is going to be the county permissible codes for, or your municipal codes for minimum height and maximum height. So your minimum height, and these heights are for your tread riser height. So your riser height is a minimum of 4 inches and 7 3/4 residential. So somewhere in between these two. And then what else is going to help us determine that is your tread depth, which is the total amount of space that your foot can step, measured from the outside edge of the tread to the outside edge of the tread. But it's actually the same measurement that you cut on the stringer. So that's 10 inches. Right? We don't want any shorter than that, or it's not to code. We don't want longer than that, because then we're cutting unnecessarily deep into the stringer. Right? We want as close to 4 inches as possible with what we can afford and go with the space that we have, and as close to 10 inches in max tread depth. That way we're cutting very small notches and we have a lot of meat left on the stringer, because that's your structural strength. Now, that is also dispersed amongst the vertical supports, posts that are every 4 feet or so horizontally. So the shallower your angle is, the more of those posts you're going to have. And obviously the more treads you're going to have, and the longer your stringer is going to need to be. So your material cost will go up, but it's also easier on the knees, and it's less effort. But anyways, let's talk about what happens when you use these numbers in calculation. So first we start with our 15 foot, and we convert that to inches. Let's multiply. I'm not just going to write equals. Multiply by 12 inches per foot. Right? And then we get 180 inches. Right? And then we're going to divide that by 4 inches, and that's going to give us how many rises there are, which is how many steps, right? So if we divide this by 4 inches, or we could write multiplied by 1 step per, which means divide, 4 inches. 1 step per 4 inches, and that's going to give us 45 steps. That's a lot, right? So let's do the same thing. We're going to actually leave that 45 over here. 45 steps on 4 inches. And then we'll do the same thing, but with the 7 3/4. Right, well, we already know that 15 feet is 180 inches. So we have 180 inches, and then we're going to divide that, or multiply it by 1 step per, so that's where our divide is, divide by 7 3/4 inches, right? And that's actually going to give us 23.22 steps, right? How do you have 0.22 steps? You don't, right? So we either have to have 23 or 24. Well, what happens if we have 23? Then we have to check with our original height. So we have 180 inches divided by 23 steps. And what's that's going to give us is actually 7.8 inches per rise, and that's not going to work. So that means this has to be 24 steps. 24 steps. So we have 7 3/4 giving us 24 steps. All right, now all we have to do is figure out what this angle is and figure out what this length is. So once we have the number of steps, figuring out this length is easy because we can just take the number of steps and multiply it by the depth of each step, the tread depth, which is 10, right? So 45 steps is going to be 450 inches, right? And then we multiply that by 1 foot per 12 inches, and that'll give us 37.5 feet, right? 37.5 feet, right? Okay, now we can do the same with this one, and we have 24 times 10, which gives us 240 inches, right? 240 inches essentially divided by 12 or multiplied by 1 foot per 12 inches, right? And then this inches and this inches cancel, and we end up with 240 divided by 12, which is 20. So that gives us 20 foot. So that means our concrete pad has to line up somewhere between 20 foot and 37.5 feet. And if we're trying to save our knees, we're going for 37.5 feet and just spending a ton of money on materials. And if we're going for least cost in materials, we're shooting for this 20-foot mark. So, and then the what the angles end up being is to calculate the angles, you use your triangle measurements and trigonometric functions. You're actually using the arctangent, but I'm not going to bore you with that, and I will just show you what it is. 4 inches will give you an angle here of 21.8 degrees, and 7 3/4 will give you 37.7 degrees. So if you're at 40, you're already outside of the window of angles, right? And you can subtract these numbers from 90 to get you the angles up at the top. And then you can use an angle laser tool to figure out exactly where you want it to go, staying within this window. And then once you have the pad poured and your stringers aligned on top, set on top, you can start to refine these numbers and get it exact. And then you'll be able to mark your stringer exactly where you want it, cut exactly where you need to. The biggest reason why people trip on stairs is because, not because they misjudged where the step is, but because your brain tells you exactly where each step is supposed to be based on the last few steps. And so if all the steps look uniform, your brain assumes that they are when you're walking. And that's why most code requires there to be no bigger difference in the rise height than 3/8 of an inch from the largest rise height to the smallest rise height in the same set of stairs. So that means you're getting them really close. They should all be pretty close to the exact same. But you don't want to just pick numbers for your rise height and your tread depth and just start cutting. You got to figure out this first, and then once you've got your calculations, it's pretty easy as far as marking them, cutting them. The other big mistake that people make is they use a skill saw, a circular saw, to cut, and they overcut this into the stringer on both directions just because they don't want to get out another tool. Because when you stop your skill saw blade here, in both directions, it's still attached because the blade is circular and it has a little bit of wood meat left over here. And in order to cut that without cutting too far into the stringer, you have to use a reciprocal saw, or I prefer a jigsaw because it cuts straighter and there's less, you know, collateral damage. But anyways, if you overcut into your stringer, your little bit of meat that's left on the stringer, you're cutting even further into that, and you're allowing for gaps for water to get in and, you know, rot it out faster. So anyways, there's my take.